In the blink of an eye, a modern bullet can travel the length of 3 football fields. It's a marvel of engineering, tiny, powerful, and the result of centuries of innovation. Today we'll explore how bullets evolved from simple metal lumps to high-tech projectiles. Why are they shaped the way they are? Why these materials? Every detail is intentional, born from relentless testing and problem-solving. We'll break down the science, history, and design behind these small but mighty objects. Forget Hollywood myths. Real bullet design is far more fascinating. This is a story of human ingenuity and our quest to master the laws of nature. Let's dive in and uncover the secrets behind the bullet. What is a bullet? It's a word we hear all the time, but what does it really mean? Most people call the whole thing you load into a gun a bullet, but that's actually a cartridge. The cartridge is the complete package that makes a firearm work, and it's made up of several important parts. The bullet is just the tip, the part that actually leaves the barrel and travels toward the target. It's the only part that ever leaves the gun. The cartridge includes the case, which holds everything together, the primer at the base, the propellant inside, and the bullet at the front. Each component has a specific job in making the shot possible. When the trigger is pulled, the firing pin strikes the primer, igniting it. This sets off the propellant, which rapidly burns and creates hot gas and pressure, launching the bullet out of the barrel at incredible speed. The bullet's shape, weight, and material are all engineered for a specific purpose: accuracy, expansion, or penetration. Some are designed to travel long distances, while others are made to expand on impact. Whether for target shooting, hunting, or self-defense, each bullet design solves a unique problem and is chosen for a specific reason. When we talk about bullets, we're talking about the projectile itself, how it's shaped, how it flies, and why it works the way it does. Its design affects everything from speed to accuracy. The cartridge is the delivery system, the bullet is the message. Without the cartridge, the bullet would never reach its target. Understanding this distinction is key to appreciating the science and engineering behind every shot, and it helps us see just how much thought goes into every round of ammunition. The bullet's story begins centuries ago, with the earliest firearms, simple, handcrafted weapons that launched round stones or lead balls from smoothbore muskets. These primitive projectiles were a far cry from what we know today, but they marked the dawn of a new era in warfare and hunting. Early shooters relied on these basic weapons, often facing unpredictable results with every shot. Lead soon became the material of choice for bullets, prized for its density, malleability, and the ease with which it could be cast into shape. This allowed for faster production and more consistent ammunition, giving armies and hunters a crucial advantage. Yet despite these improvements, accuracy remained a major challenge. Smoothbore barrels sent round balls flying in unpredictable arcs, making it difficult to hit targets at any real distance. Soldiers and marksmen had to get dangerously close to their targets, limiting tactics and effectiveness. The breakthrough came with rifling, spiral grooves cut inside the barrel. This innovation caused the bullet to spin as it traveled down the barrel, stabilizing its flight and dramatically improving accuracy and range. Enter the mini ball, a revolutionary conical hollow-based bullet. When fired, it expanded to grip the rifling grooves, making loading much easier and shots far more accurate. This simple change had a profound impact on the effectiveness of rifles in battle. The mini ball's success transformed warfare, allowing soldiers to engage enemies at greater distances and with deadly precision. It set the stage for the rapid evolution of bullet technology that would follow. As firearms advanced, designers experimented with new bullet shapes to improve aerodynamics. This led to the pointed Spitzer bullet, which sliced through the air more efficiently, increasing both range and accuracy. The next leap was the addition of a copper jacket around the lead core. This innovation allowed bullets to withstand higher speeds without deforming and reduced fouling in the barrel, making firearms more reliable and easier to maintain. From simple spheres to complex jacketed projectiles, the bullet's evolution is a story of relentless pursuit, driven by the desire for greater speed, accuracy, and performance. Each new design built on the lessons of the past, pushing the limits of what was possible. Every leap forward in bullet technology was inspired by the need to solve real-world problems, on the battlefield, in the hunt, and beyond. The bullet's journey is a testament to human ingenuity and the constant drive to innovate. Inside a modern ammo factory, precision and speed rule. It starts with two main parts, a soft lead core and a copper alloy jacket. Lead wire is cut and pressed into shape, copper cups are drawn out and thinned. Both must be nearly identical. Tiny differences can ruin accuracy. The lead core is inserted into the jacket, then pressed to form the final bullet shape. The nose is shaped for its intended use, round for pistols, pointed for rifles. After polishing and quality checks, the bullet is ready for loading. This process turns raw materials into high-performance projectiles in seconds. It's a showcase of modern engineering and manufacturing at its finest. Pull the trigger, and a fascinating chain reaction begins. Inside the firearm, the firing pin snaps forward, striking the primer at the base of the cartridge. This tiny but critical impact ignites a small explosive compound within the primer, which in turn sets off the main propellant charge packed inside the cartridge case. As the propellant rapidly burns, it produces a surge of hot, expanding gas. This gas builds up immense pressure behind the bullet, forcing it out of the cartridge and down the barrel at incredible speed, accompanied by a flash of light and a burst of smoke. Inside the barrel, spiral grooves called rifling grip the bullet and spin it rapidly. This spin stabilizes the bullet, much like a quarterback spinning a football, ensuring it flies straight and true toward its target. The spinning motion is crucial for accuracy, keeping the bullet point first as it slices through the air, minimizing wobble and deviation from its intended path. Once airborne, the bullet is at the mercy of physics. Gravity immediately begins to pull it downward, while air resistance works to slow it, causing its path to arc and its speed to gradually decrease over distance. That's why bullets are designed to be streamlined and pointed, to reduce drag, cut through the air efficiently, and maintain as much speed and energy as possible on their way to the target. The science of external ballistics helps shooters predict a bullet's path, taking into account not just gravity and air resistance, but also wind, temperature, humidity, and even the subtle effects of the Earth's rotation. Every shot fired is a real-world demonstration of physics and chemistry in action, where countless variables come together in a split second to determine the bullet's journey. The entire process, from the initial explosion to the bullet's flight through the air, happens in just a few milliseconds, almost too fast for the human eye to see. It's a perfect blend of science, engineering, and precision, all coming together for one precise, powerful moment when the bullet leaves the barrel and begins its journey. The quest for the perfect bullet never ends. Engineers constantly experiment with new materials, shapes, and technology, like heat-resistant tips and lead-free designs. Advanced tools like computer modeling and radar help refine every detail. The goal, more accuracy, efficiency, and consistency. Bullets are a lens into human ingenuity. Every improvement tells a story of problem-solving and innovation. We've only scratched the surface. There's much more to explore, from terminal ballistics to propellants. What part of this story fascinated you most? Let us know in the comments. The science of bullets is always evolving. Let's keep learning together.